Hello everyone. So in the last video we discussed 14.1. We've covered 14.1. Now moving to 14.2, the rank of a matrix. So it is a very important topic. So the chapter 14 whole is very important, and rank of a matrix, this would help us in finding the solution, whether it is unique, whether it exists or not, and whether it is unique or not. So this will cover in 14.3. Before this, let's check what rank of a matrix is. So it is denoted by Ra, and it is the maximum number of linearly independent rows or column vectors in. So it is the maximum number of linearly independent column vectors in A. And it can be written as maximum number of linearly independent row vectors in A as well. Okay. Now if A is any zero matrix, then rank of A is 0. Now we'll discuss in bit detail how we are supposed to find the rank of a matrix using two methods. Okay. Just example 14.3. If A is a square matrix of order n, so maximum number of linearly independent column vectors in A. So if it is of order n, then the matrix has n rows and n columns. And since it has a total of n columns, so the maximum possible linearly independent column vectors are n only. It cannot be more than n because the columns are n only. So the rank of A should be less than equal to n. So n column vectors of A are linearly independent if A determinant is not equals to 0. So for a given matrix, if A determinant is not equals to 0, then the square matrix would have rank n. So a square matrix has rank n of order n. So it was an n cross n matrix, and if the A determinant is not 0, then the rank of A is n. Okay, now we'll discuss about the minor. What a minor is. A minor of order k in the matrix A is obtained by deleting all but k rows and k columns of A, and then taking the determinant of the resulting k cross k matrix. So basically, if we have a matrix 5, 4, so 5 rows and 4 columns, 1, 2, 3, 4. Now we can remove, so a minor of order 3 cross 3 or 4 cross 4. 4 cross 4 would be, if you remove either the first row, then you will have 1, 2, 3, 4 rows and 1, 2, 3, 4 columns. So this is a minor. Accordingly, if you remove the second row, and then it would be first row, third row, fourth row, fifth row. So I'll discuss in detail. Okay, so let's do an example. This will make things more clear. Now example 14.4, describe all the minors of the matrix A. So firstly, write the order of A. 1, rows are 1, first row, second row, third row, and columns are 4. So 3 cross 4. So the minors would be 3 cross 3, because the definition of a minor of order k is obtained by deleting all but k rows and k columns. So order we can have for minors as 3 cross 3, and then 2 cross 2 and 1 cross 1. Now looking at 3 cross 3. So if we remove the first column, this would be our minor. So finding the determinant of this would give us the minor of this particular. Okay, so in this particular question, so if we'll see, the minors are, the first minor is, okay, this is, now if we're talking about order 3, the first minor would be if you remove the first row, first column. So it is, first is 0, 2, 2, 2, 4, 2, 1, 2, 1. Second is, suppose you remove this row and it would be 1 0 1 0 0 2 4 2 1 2 1. Similarly, you can remove the third row and then the fourth row. So you will see you will have four orders, four minors. So removing the third row, 0 0, third column, sorry, 1 2 1. Then the fourth is removing the last column, 1 0 0 0 2 2 2 4 2. So here we have four minors of order 3. So I'm telling you about the minors because this would help you in finding the rank of a matrix as well in the next few classes. In the this we will study. Okay, so we have this. Now I'm marking in red the 2 cross 2 minors that we'll have. Firstly, talking about 1 cross 1 minor of order 1. Minor of order 1. So basically one row and one column. So all these are minors of order 1. So we have 12 minors of order 1. Now if we are talking about minors of order 2. Okay, so it is 2 cross 2 this, then this is also possible, this is also possible, this is also possible, this is also possible, and removing this thing and this thing is also possible. So you will see there are many possible minors of order 2. Okay, so now I'm hoping that you are aware that how we are supposed to find the minors. Now we will discuss how rank of a matrix is dependent and the relation between the minor. Okay, the rank A of a matrix is equal to the order of the largest minor of A that is different from 0. So basically जो हम rank A निकाल रही है वो क्या है, जो हमारा order है largest minor का, order of largest minor that is different from 0, that is not equals to 0. एक will do one question and this will make things very clear, but फिर से एक बार बता देता हूँ. रैंक ए क्या है, सॉरी this was order. Rank A is equal to the order of the largest minor which is not equal to 0. Okay, now ठीक है, we have ample space to complete here. Now the order of the A matrix is 1 2 3 3 cross 4, right? Now looking at, so we know that we'll get minors of order 3. So the order 3 minors would be, first one would be -1 -2 -3. So removing the last column, 0 2 1 2 4 6, and we will check whether the determinant is coming out to be 0 or not. So this is -1 into -1 into 12 minus 4 plus 2 into -2 plus 6. So this is -8 plus 2 into 4, which is 0. Okay, so this, firstly we'll write all the 3 cross 3 minors. Okay, firstly, then now in the second minor what we'll do is we will remove this and then write the -1 -2 -3 0 2 1 1, 2, 3. In the third minor will remove this, and other elements would be same, -1, -2, -3, then 2, 4, 6, 1, 2, 3. And the last one will remove the first element only, so it would be 0, 2, 1, 2, 4, 6, 1, 2, 3. Now this is coming out to be 0 and we need to check. So अगर order 3 में one of the minor is not coming out to be 0, then the rank of the matrix of the whole matrix is 3. But अगर सबका, जैसे order 3 के 4 minors आए हमारे पास, right, and in सबका determinant, if it is coming out to be, if the determinants of all the minors of order 3 is coming out to be 0, then we will check the determinant of order 2. And अगर माइनर ऑफ ऑर्डर 2 का डिटर्मिनेंट चेक करेंगे, अगर ये भी 0 आ रहा है देन फिर 1 का करेंगे, बट अगर ये 0 नहीं आ रहा देन द रैंक ऑफ ए वुड बी 2. ओके, हमने इसको चेक किया, दिस कमिंग आउट टू बी 0. नाउ you can see, observe from this the rules of determinants, the first column and the second column. So basically C1 is equals to minus C3. Since they are in a equal proportion, the determinant is 0. You should know this. In this case, look at these two columns. C3, 2 times C3 gives you C2. So basically C3 is half times C2. So in this case also the determinant would be 0. And in this case also the same thing, determinant is 0. So what we can say is that we are sure that for this given matrix, जो हमने order 3 के minors लिए, सबकी value 0 आ रही है. So we will check for order 2. And order 2 में suppose we take this. Okay, -1, 0, -2, 2. The determinant of this is -2. This is not equals to 0. So we can come to the conclusion that the rank of this given matrix is 2. The largest order for which the minor is not equals to 0. Okay, I hope this is clear. Moving forward, now you are supposed to find the rank of the matrix for all values of x. Now it is 3 cross 3. The first minor is the matrix itself. So if you are talking about order 3, the minor is the matrix itself A, which is, so this is determinant sign, 5 minus x, 2, 1, 2, 1 minus x, 0, 1, 0, 1 minus x. So if this determinant comes out to be 0, then we will check for minor of order 2. But if this doesn't come out to be 0, then the rank of the matrix is 3. So just find out what the determinant would be in this case. I'm giving you a minute or so. So you need to check for what values of x will the rank be 3, and for what value of x would the rank be less than 3. It cannot be greater than 3 because the maximum number of independent rows or columns cannot be greater than 3. Okay, so solving this along, suppose this row, this is A31, so positive sign. So 1 times 2 into 0, 0 minus 1 minus x, 2 into 0, 0 minus 1 minus x, minus 0 times something 0 only, plus 1 minus x times 5 minus x into 1 minus x minus 4. So what we have is 1 times minus 1 plus x plus 1 minus x times 5 minus x. Okay, I should write it somewhere else, minus 4. So if we'll solve this, we'll get 1 plus x plus 1 minus x times 5 minus 5x minus x plus x square minus 4. So okay, so 1 minus x you can take common. So if you take 1 minus x common, this becomes minus 1, and then with plus 5 minus 5x minus x plus x square minus 4. So you can solve this. This would be 4 would cancel out. So 5 minus 4, this cancels out. So you are left with x square minus 6x. So this is coming out to be 1 minus x into x minus 6. So this is the value of determinant that you are getting. Now in this case, if the determinant is 0, if the so we'll take two cases. If determinant is not equals to 0, if the determinant is not equals to 0, and that would happen when x is not equals to 0, x is not equal to 1, x is not equal to 6. So in this particular case, when determinant is not equals to 0, we'll have rank of A equals to 3. But on the other hand, if this equals 0, and this is possible when x equals to 0, x equals to 1, or x equals to 6, then we will check the minor of order 2. So suppose x is 0, and then we check the minor of order 2. This would become, if we check this, this would be 5, 2, 2, 1. Determinant of this 5 minus 4, which is 1, which is not equals to 0. So then we can come to the conclusion that rank of A in this case would be equal to 2. I hope this was clear. Now moving forward. Now coming to theorem. Okay, so this is, you should know that rank of a matrix A is equals to the rank of the transpose of matrix A. One more important thing, this rank is not affected by elementary row operations. So if you're using elementary row operations, it won't impact the rank. Now I'll tell you how you're supposed to find the rank of a matrix with the help of elementary row operations. So suppose I'll tell you how we are supposed to proceed. First, make this element as 1, and then the diagonal element as 1, and then this diagonal element as 1. So this is a 1, 2, 3, 3 cross 4 matrix, and rank is the maximum number of linearly independent rows or columns. Since there are only 3 rows and 4 columns, so the maximum number of rows which is possible are 3. So the rank of A should be always less than equal to 3. On the other hand, if you think from the perspective of the minor thing that we have discussed, so order first minor ka hoga 3. So rank cannot be greater than 3 in this case. This is not possible. Okay. So this much is done. Now we'll try to find the rank. The first operation would be R2 goes to R2 minus 2R1, and simultaneously we'll make this as 0, this as 0 as well. R3 goes to R3 minus R1. So the transformed matrix would be 1, 2, 3, 2, 2 minus 1, 0, 3 minus 4 minus 1, 5 minus 6 minus 1, 2, 1 minus 4 minus 3. This would be 0, 1, 1, 3. Now make this as 1. So we'll use the operation R2 goes to minus R2. So this would become plus plus plus, and then making this as 0, R3 goes to R3 minus R2. So we'll make this 0 with the help of this. So we have 1 0 0, 2 3 2, 1 1 3. This would become 0, this would become 0, this would become 0. So we have this and this. So these two rows are linearly independent. So the rank of A would be 2 in this case. And this is a 0 0 term. Had it been the case if we had a 1 here, so then we could have rank of A equals to 3. But in this particular case, we are having a rank of A equals to 2. Okay. Now let us find the rank of this using our elementary row operations only. First thing, this is 1 only, so we'll make this as 0 and this as 0. Now R2 goes to, firstly you should know it is a 3 cross 4 matrix and rank of A cannot be, should be less than equal to 3. It cannot be greater than 3, the minimum of this. Now R2 goes to R2 minus 2R1. I'm again telling you that using elementary row operations won't impact the rank of the transformed and the original matrix. It would remain the same. And R3 goes to R3 plus R1. Now 1, 2, minus 1, 3. I would prefer that you solve this on your own. I'm giving you 2 minutes to solve this, and then I'll move forward. It's 2:15. I'll give you time till 2:17. Okay, the first operation would fetch you 2 minus 2 0, minus 4 plus 2 is minus 2, 7 minus 6 is 1, 0 0, minus 2, 1. So you will see if you divide this by, okay, now R2 goes to minus 1 by 2 R2. So this would be 1 0 0, 2 0 0, minus 1 1, minus 2 3, minus half 1. Now R3 goes to R3 plus 2 R2, making this as 0, minus 1 1, 3, minus half. This would become 0, this would become 0. So ideally we have this not in the column but here, so that would also work, and rank of A in this case would be 2. Had it been the case that all these elements were 0, then the rank of A would have been 1. Okay, now moving forward, Now suppose you're supposed to find rank of this. This is 2 cross 3. So you already know that rank of A should be less than equals to 2. Now using the elementary row operations, R2 goes to R2 minus 3R1. So in this case 1 0 2, 3 minus 1 0, 8 minus this is 8, 5 minus 1. So this now we have R2 goes to 1 by 8 R2. So this becomes 1 0 0 1 2 minus 1 by 8. So we have two independent rows. So the rank of A in this case is 2. Now suppose for what values of x we need to find that rank of A would differ on the basis of values of x. So firstly, you can solve this with the help of the minor thing. So the order is 2 cross 2, and if the determinant, so if you're talking about of order 2, we have only one minor, and if that the determinant of this minor is comes out to be 0, then we'll check for 1 cross 1, then we'll check for order 1. Okay, now the determinant of this minor would be x minus 3, 2x plus 1, 2, 5. So determinant would be 5 times x minus 3 minus 2 times 2x plus 1. So this becomes 5x minus 15 minus 4x minus 2. So this is x minus 17. And if this is 0, then the rank of A is not equals to 2. If this is 0, so it is 0 when x equals to 17. So when x is 17, rank of A is not equals to 2. But when x is not equals to 17, rank of A is 2. I hope this is clear. Now suppose x is 17. So if x is 17, this would become 14, 2, 35, 5. And now for order 1, how many minors are there? 4. 1, 2, 3, 4. And none of them is 0. At least one of them is not 0. So rank of A when x equals to 17, because when x was 17, the minor, the 2 cross 2 minor was giving you the value 0. So we'll consider order 1 minors, and they are not 0, so rank of A would be 1 in this case. And in the next class onwards, we'll start with 14.3. So we'll cover the how the rank influences the solution, that is whether the solution would exist, it would be unique, or it would be infinitely many solution. And this is also important. So the chapter 14 whole is very important. It is important. So I would suggest, so okay, I have already share you the link for the group, and I'll be discussing various important questions in it. So it would be like for every 2-3 days I'll discuss one question on it, and you're supposed to solve it. That would actually enhance your confidence, because if you keep on solving the questions now, it would help you in the later part of the course. Okay, thank you.